Hello everyone. Today we'll continue with first order circuits and we will look at the forced response. So the summary or overview is very much the same. We're still trying to be able to analyze first order circuits in their completeness. So the idea here is now we looked at the natural response and we would like to see what happens when we have the step response, which is when they're connected to a switch. So the step response corresponds to a scenario where you apply a voltage across a capacitor. It could be an inductor, so we'll look at the inductor scenario next. But when you have a capacitor and it's directly applied to a voltage source, then you have the step response of the circuit. We're going to consider the circuit that we're seeing over here, and what we're going to look at now is what is the voltage going to be at time smaller than 0, and what happens at time greater than 0 when the switch is closed. So if we assume that the capacitor has an initial voltage that is denoted by V0, what we can do is now look at KCL by looking at the currents throughout the circuit. So what we have is that by going around this loop, what we have is Vs divided by R, which is the Vs divided by Rc is equal to V divided by Rc plus dV dt. And so that follows from first writing a mesh equation around the loop that we saw there. And so we will actually go in detail over how we arrive at this expression in class. But if you look at the scenario where t is greater than 0, then we can remove this u of t, which is the step function, which we discussed in the previous lecture. And we arrive at the following set of expression, or the following expression. And if we integrate both sides of this expression, or if we solve this first order differential equation, which you all know how to do at this point quite well, then we arrive at the following expression. So when we're integrating this expression, we're only looking at the case where t is greater than 0. For t smaller than 0, the expression is quite clear, and that is the voltage across the capacitor is what it started with, the initial voltage. But when we do the integration, we arrive at this expression for v of t. So, and now we have a very good understanding of what the step response of the circuit is going to be. So what we're looking at here is the complete response of the circuit, or you can refer to it as step response, but it's also a complete response. We start from a voltage V0, and basically the voltage increases to finally stabilize or reach a steady state at V of S. So what we can say is that the overall response of the circuit can be divided into two steps. One is the natural response of the circuit, which is when the capacitor is discharging. And the second one is the forced response of the circuit, which is basically the capacitor fully charging. If we look at the natural response and the step response, and we add them, the forced response, and we add them together, we would again arrive at this the step response, or the full or complete response of the circuit. So let's have a look. If we say that the overall voltage is given by the natural response of the circuit plus its forced response, then we can write down what is the natural response. The natural response is given by the original voltage multiplied by e to the power minus t divided by the time constant, which is tau. And then we have the final, the forced response given by v of s times 1 minus e to the power minus t divided by tau. And that would be the forced response. The eventual response is given by the sum of these two responses, obviously, which is v0 e to the power minus t divided by tau plus vs times 1 minus e to the power minus t divided by tau. And so that would be one way to arrive at this complete response of the circuit. Another way to think about this is that we could consider the transient response and the steady state response of the circuit. The transient response is obviously the response of the circuit when transitioning from the V0 voltage to the V of S. And the steady state response is when the voltage actually has reached the V of S, right? That's the final step. And so if we sum the transient response and the steady state response, we will again find the complete response of the circuit. So there are two ways to look at this, and as I always say, you should find a way that makes the most sense to you. We could look at the forced response and the natural response of the circuit, or sum them together, and that would give us the complete response or the steady state response. Or we could look at the transient response, which is the transition, plus the steady state response, and again that would give us the step response of the circuit. So that's one thing that we could look into and discuss more as we solve problems in class. Thank you.